Hello students, we are studying basic principles of organic chemistry, and in this video we will be starting with the new topic called types of reagent. Students, if you all remember the parameters of an organic reaction, there is substrate, there is reagent, catalyst, product and byproduct, right? So what is a reagent? Reagent is something which brings about change in our substrate. Okay, so now we will be seeing what are the types of reagent available. So students, in polar organic reactions, okay, the polar organic reactions are brought about by two types of reagents. So if you all remember, the organic reactions which are proceeded via heterolytic fission, okay, heterolytic fission is the topic discussed in previous video. So the reactions in which the covalent bond cleavage happens because of heterolysis, such type of reactions, they are known as heteropolar or maybe polar or maybe ionic reactions. So now we will be seeing what are the types of reagent in a polar organic reaction. Okay, so there are two types, electrophiles and nucleophiles. Okay, so electrophiles, they are generally written as E with a positive sign, and nucleophile is Nu, and this is indicating a pair of electron. Okay, the two dots, they are nothing but a pair of electrons. Okay, fine. So what are electrophiles, students? Electrophiles and nucleophiles both. So why are there two types of reagents? Depending upon their ability to accept or donate electrons from or to the substrate, reagents are classified. Okay, as we discussed that reagents are something that bring about changes in the substrate, right? And your bond breaking, bond forming involves, obviously it has involvement of electrons, right? Now whether your reagent will donate electron to the substrate or whether it will accept electron from the substrate, okay, based on that it is classified as electrophiles and nucleophiles. Okay, so what is an electrophile, students? Electrophile is something that is electron loving in nature. It is an electron loving species. They accept electrons from the substrate. Okay, so the reagent electrophile, as you all can see, it is E plus, right? So it is very obvious that it is electron deficient in nature and it needs electron. So electrophiles will accept electrons from the substrate, okay, because they are electron deficient in nature. For example, your Br plus. Okay, and what is a nucleophile? Nucleophile is nucleus seeking species. Okay, they give away electrons to the substrate. As you all can see, this is the general form how a nucleophile is represented. Nu and these two dots are nothing but a pair of electrons. So they are nucleus seeking species. They need positive charge. Okay, they go attracted towards positive charge. Alright, and you all can, as you all can see, they have extra electrons. They are electron rich in nature. So they'll give electrons to the substrate. For example, OH minus. Okay, so electrophile is something that will accept electron from the substrate. Nucleophile is something that will donate electron to the substrate. Okay, students, so very important topic, electrophiles and nucleophiles. This is going to repeat in many chapters and even in your 12th standard. So please see to it that you all understand it. Now students, let's talk about polyatomic electrophile. Okay, in a polyatomic electrophile, there has an electron deficient atom in it called electrophilic center. Okay, fine. Polyatomic electrophile is a compound. Basically we are talking about a compound. Alright, a compound in which electrophilic center is present. Okay, fine. Now students, what is an electrophile? Electrophile is something that is electron deficient in nature. Okay, fine. So it has the tendency to accept electrons from the substrate. Now see, there are neutral species which can act as electrophile or nucleophile. Okay, they act as, now neutral species, see, for example, you all can see this compound AlCl3 over here. This compound is your aluminium chloride. Okay, now see students, in this aluminium chloride compound, overall there is no charge. Alright, it is a compound, it is neutral in nature, but it is not like that. This acts as a polyatomic electrophile. Why, students? Because it has an electrophilic center in it. Now in this AlCl3, Al is electrophilic center as it has only 6 valence electrons. In this compound, the octet state of Al is not yet fulfilled. It has only 6 electrons. So it is electron deficient, right? So in this polyatomic electrophile, we have Al as the electrophilic center. Students, the structure of this compound is like this. Okay, your Al surrounded by 3 chlorine atoms. So here in this polyatomic electrophile, your Al has only 6 electrons. It has still not completed its octet state. So it is electron deficient. So this acts as an electrophilic center. Okay. If I talk about polyatomic nucleophile, so polyatomic nucleophile has an electron rich atom in it called the nucleophilic center. Okay, so if any compound, for example H2O, your water, okay, it is a neutral compound. Okay, fine, but in this compound the oxygen has 2 lone pair of electrons, so it is the nucleophilic center. This is the structure. Okay, HOH, this is the structure of water. Alright, you all can see oxygen here acts as a nucleophilic center because see, what is a nucleophile, students? Nucleophile is something it is a nucleus seeking species, right? It means it has extra electrons, it wants to give away its electrons. So you all can see here our oxygen atom has 2 lone pair of electrons. Okay, see, what are lone pairs? Lone pairs are extra electrons. Okay, you all can see here overall there are 4 dots on oxygen, that is it has overall 4 electrons extra, which means it has 2 pairs of electrons extra. So these extra pairs are known as lone pairs. Okay, fine. So here in this neutral compound, in this polyatomic nucleophile, oxygen is my nucleophilic center. Okay. Students, if you all want to understand a little more about lone pair, the topic lone pair, see, your oxygen has atomic number 8, right? So the distribution of electrons in this is like 2 and 6. In the first shell there are 2 electrons, in the second shell there are 6 electrons. This second shell is the valence shell for oxygen. Alright, and the valence electrons in that shell, how many number of electrons are present in the valence shell? 6. Okay, for oxygen. So now in bond sharing, whenever covalent bond etc. is formed, alright, these electrons of the valence shell are going to participate. Alright, now if I talk about HOH, that is our water molecule, how many electrons are present in the valence shell of oxygen? 6. Now in that, 1 electron is here, other electron is here. Okay, because this is a covalent bond, right? And 1 electron is given by hydrogen, and here also this hydrogen gives electron. So this is how a covalent bond is formed. Now here oxygen is contributing 2 of its electrons, which means out of the 6 electrons, okay, out of the 6 valence electrons, 2 have been used up. But what about the remaining 4? Okay, what about the remaining 4? So the remaining 4, they'll be paired up and they'll stay as it is over here. Okay, so they have not been involved in any bond formation or anything. Alright, they are extra electrons. Okay, which have some purposes. You can use these extra electrons, but let's not get into that. So just remember that these extra electrons, so it means oxygen has 2 lone pair of electrons. Okay. Okay students, so now we will see what is an electrophilic reaction and what is a nucleophilic reaction. Okay, so students, in electrophilic reaction what happens is that our electrophile, okay, our electrophile attacks a nucleophilic center in the substrate. Okay, electrophile will attack the nucleophilic center, alright, in our substrate. And what is a nucleophilic reaction? In nucleophilic reaction, our nucleophile attacks the electrophilic center of the substrate. I hope we just discussed what is nucleophilic center and electrophilic center. Okay, in polyatomic electrophile. Okay, the example was AlCl3. So here Al is the electrophilic center, which is electron deficient in nature, and in our polyatomic nucleophile, that is example water, oxygen is the nucleophilic center, that is it is electron rich in nature. Okay, it has extra electrons. So what happens in an electrophilic reaction is that an electrophile, okay, an electrophile which is electron deficient in nature, it will go and attack a nucleophilic center. Why? Because on a nucleophilic center there are extra electrons. Whereas if I talk about a nucleophilic reaction, a nucleophile which has extra electron, which is electron rich in nature, it will go and attack an nucleophilic an electrophilic center, this nucleophile which is electron rich in nature, it goes and attacks an electrophilic center. Why? Because this electrophilic center is deprived of electrons. Okay, let us take an example to understand this. You all can see your NH3 reacts with BF3 to give you this intermediate, this complex compound. NH3 is your ammonia, okay, and BF3 is boron trifluoride. So students, here what is happening, nucleophilic center, nitrogen, you all can see on nitrogen there are 2 electrons, that is nitrogen has 1 lone pair of electron, okay, which means in this compound, in this polyatomic nucleophile, okay, in this polyatomic nucleophile, nitrogen is my nucleophilic center. And if I talk about BF3, so in BF3 students, boron is electron deficient, okay, fine. So in this polyatomic electrophile, boron is my electrophilic center, okay. So now here what is happening, nucleophilic center, okay, see our nucleophile is going and attacking, okay, nucleophile is going and attacking the electrophilic center, okay. So your nucleophilic center N attacks the electrophilic center boron, okay, fine. And what happens here, it means basically in this reaction what is happening, this nitrogen is giving away its electrons to boron, so it acquires a positive charge, alright, fine, and boron will acquire a negative charge and they are joined together by a bond formation, alright. Now students, see the atomic number of nitrogen is 7, right? So the electron distribution is 2,5, okay. In the first shell there are 2 electrons, in the second shell there are 5 electrons, alright. Now to complete its octet, you all can see in the valence shell, okay, the second shell is the valence shell. In valence shell there are 5 electrons, alright. So to complete the octet, it needs 3 more electrons. That is the reason nitrogen forms 3 bonds, okay, it has valency 3. Now this nitrogen will form 3 bonds with hydrogen, okay, I am talking about ammonia. This nitrogen has contributed 1, 2, 3, like out of these 5 electrons, 3 electrons of nitrogen have undergone covalent bond formation, okay. Electrons are given by hydrogen as well, that is how a covalent bond is formed. Now you all can see students, this nitrogen, out of the 5 valence electrons, 3 have undergone bond formation and 2 electrons are still left. That is the reason nitrogen has 1 lone pair of electron. And if you see overall, okay, the 5 electrons are of nitrogen plus the 3 electrons from these hydrogen atoms. So it has completed its octet, okay. That is the reason compounds, elements undergo compound formation, so that they acquire a stable state, alright. So we can see nitrogen has 1 lone pair, that is extra, 1 pair of extra electrons which can be used later, alright. So this was an illustration of how nucleophilic and electrophilic reaction happens. So students, we are done with this topic. The remaining topics we will see in the next video. Thank you.